you get the word, we're only gonna have 2 days, not 4. Because, as you can see, it's been videotaped, which means there can be limitations on what I can do. I understand there's going to be CDs available in the library. Also, you can buy them at Walmart. And God knows where else. The main thing you want to remember, who in here is taking about reviews for Rainbow? Okay, if you take those, remember they are reviews. They are no substitute for your material. Regardless of what you hear. You want to, even if you don't have time to go over your notes 100%, even if you cover 50% of your notes, it's better than not doing anything and relying on the reviews, period. The material comes, the exams come from the notes, not from those reviews. So concentrate on those would be better off. What we're going to do is just basics, remind you. And I'll tell you to go over your notes again, which would be just as quick. When you go over your notes, you don't have to sit and memorize anything. You get the impression that you have to sit there and memorize and you don't have time to do that. Don't. You already memorized the stuff, you already know the stuff. What you want to do is read them. Just read them. You'd be surprised how much will come right back to you during the exam. You pop in your head right away. If you just read them. Because the exam is recognition, not recall. You don't have to come up with it from the book. But in front of you, it'll come back to you, you've read it. So just take time to read your notes. It'll be a lot quicker than you think it is. Okay. The basics, you can combine, I'll tell you about other things that you want to look at too. But, let's start with the vesicles. You're almost guaranteed to have some questions about that stuff. Then I want to go over some tech parasympathetic pain postganglionic stuff. That's also very important. Can you read this stuff? What's it for? I don't know how you do that. I want to remind you, the neural tube is derived from the ectoderm, remember? And you have the depression in the tube. You have depression in the ectoderm like this. There's going to be a differentiated tissue. From the epithelium, you're going to neuroepithelium. And to do that, you need factors that will convert it. Those factors come from the mesoderm, not the ectoderm. The factors that convert epithelium into neuroepithelium, or the neural plate, is the neural plate. That's neuroepithelium. So you're converting epithelium into neuroepithelium to make that neural plate, that depression in there. The depression itself is called the neural groove. And the factors that help convert the epithelium and neuroepithelium come from mesoderm, not the ectoderm. Remember also, the ectoderm is not segmented. The endoderm is not segmented. The mesoderm is. It is muscles and skin, and derms are segmented. Then the groove gets deeper until it does this number. Now you have a wall in here. That's the tube. The tube is not the hole inside. The hole inside is a canal, the neural canal. The tube is the wall, the neural tube. It's a neural plate. that got deeper and deeper, and then you got ridges up on top, and then they close in on day 20. Also, more tissue forms over here, more neuroepithelium forms on the side. That's a neural crest. That's not tube. This is a crest. The tube will give you the CNS. The crest will give you ganglia, the sensory ganglia of the cranial nerve, the sensory ganglia of the spinal nerve, the DRG, that is, the motor ganglia of sympathetic and parasympathetic, which we're going to go over again. All of those come from neural crest, not the neural tube. It will give you the pia and the arachnoid. The dura is not derived from there. The dura comes from the mesoderm. The dura is like, remember, it's like ligaments. So it's the same material, it's connective tissue. It's mesoderm. It'll give you the sclera. And remember, some of those ganglia cells that go down to the lateral horn, to the spinal cord, over here, when you do this, those are not crests, right? Some of them coming from the crest during the 4th week of gestation keep on moving. They don't sit there, they end up sitting where on top of the adrenal gland and encased in the adrenal cortex. They become the adrenal what? Medulla. So adrenal medulla is a displaced sympathetic chain ganglia, remember? Okay. This is not real, is it? I can't imagine how you follow this stuff. You know, it's like saying, okay, there's, Is that good enough? Okay, our review. The anterior portion to the foramen magnum is going to break up into 3 subdivisions, right? Those are the primary embryonic brain vesicles. They are present between 3.5 and 4 weeks of gestation. You have the prosencephalon, the pros, the mes, and the rhombus. Cephalon means brain in Greek. The pros, that's 3.5 weeks, let's say, approximately, plus or minus a couple of days. Then those, that's primary embryonic brain vesicles, not subdivisions. Those will give us, the pros will give us 2. The mes will be the same. The rhomb will give us 2. Still, once you pass the foramen magnum, it's spinal cord by definition. The rhomb, pros means in front, mes in the middle. Rhomb is not back. Rhomb is the cephalon that contains rhomboid fossa, which is the floor of the fourth ventricle. This is a patellar cephalon. This is the diencephalon. Dien means in between, sort of like mes, which is the same thing. This is the metencephalon, and this is the myelencephalon. Those are the secondary embryonic brain vesicles. They're present by about 5 weeks of gestation. That's secondary. There are also flexures that develop by the 5th week, especially by the 6th week you have the flexures present. There are 3 of them we talked about. There is a cervical flexure which will disappear at birth, right? Between the brainstem and the spinal cord because the embryo is folded inside the womb. There is a pontine flexure which is also disappear, giving rise to rhomboid fossa. And the one that would persist in humans is what? The cephalic or mesencephalic flexure. So you're going up. and then you're going to do this. There's your mesencephalon here, your tectum. In front of the mesencephalon is flexure, the mesencephalic flexure, or cephalic flexure. So you bring the fist forward, no up, and you go in the upright posture. Of the telencephalon, the neocortex, the limbic system, corpus, striatum, and the olfactory bulb, and the olfactory cortex, or paleocortex. Paleocortex is about 4 layers of tissue, of cells. Neocortex is 6 layers. Let's look at the composition of those. This one in the center, that's the diencephalon. We'll come back to that. The corpus striatum. Contains striatum and the pallidum. Coming back, pallidum, the striatum is also called the neostriatum, or striatum. The pallidum is the paleostriatum. The striatum includes dorsal and ventral, let's do ventral first. The ventral striatum is nucleus accumbens. What's special about accumbens, do you remember? It straddles the limbic system and the corpus striatum. It straddles the motor system and the emotional circuitry. And it's very rich in receptors for what? Dopamine, remember? It's the main target of the VTA, of the ascending brainstem chemical pathway containing dopamine, right? The cocaine reception in there. The ventral, the dorsal includes the caudate nucleus and the putamen. The pallidum includes dorsal and ventral. The dorsal is the globus pallidus. The ventral, we didn't talk about it. Well, it includes nucleus of Meynert, substantia innominata, and stuff like that. The dorsal pallidum is a GP. And the GP and the putamen together form what? The lenticular nucleus, remember that? Lenticular nucleus. Then we're going to add in here, we're going to add the substantia nigra, and we're going to add the subthalamic nucleus. And all of this is called what? Basal ganglia. The corpus striatum is in the telencephalon. The nigra is in the mesencephalon. Subthalamic nucleus in the diencephalon, subthalamus. What brings them together is that they're heavily interconnected and they're all involved in what? Motor circuitry. Remember? The main pathway you want to remember is the one going from SN C to the striate to caudate putamen. That pathway, I'm almost certain you'll hear about it somewhere in the line. That's a nigrostriatal pathway, or tract. It's a nigrostriatal from SNC, nigrostriatal. The striatum being the caudate and epithelium, right? The neostriatum, striatum. That pathway is the dopamine pathway, the dopaminergic pathway. Right? The signal coming back down from here goes back down to SNR. And that's not dopaminergic, that's GABAergic. The dopaminergic pathway, you remember, there's a D1 and a D2, one's excitatory, inhibitory. Ultimately, the signal from caudate putamen go to the globus pallidus. Eventually, you're going to go to the GP, which is going to go to the thalamus. And the GP to thalamus is inhibitory. Output of GP is inhibitory, it's GABA. And thalamus goes to cortex, to neocortex. Especially areas 4 and 6, especially those, the ones involved in motor control. Let's look quickly at some areas of the neocortex, and then with the limbic system. Central fissure, fissure of Orlando. Lateral fissure, fissure of Sylvius. Don't confuse this as horizontal. The horizontal one is where in the cerebellum, even though that one is horizontal little. Frontal, parietal, occipital, temporal. The areas, 17, they're not going to ask you about areas, but about the function or their names. I doubt they'll ask about the numbers. And you have 18 and 19. 17 is the primary visual cortex or striate cortex. 18 and 19 are secondary visual areas. And here we have 41 and 42. Those are in the superior temporal gyrus. They are said to be the primary auditory areas, or the transverse gyri of Heschel. That's Heschel, that's striate cortex, not corpus striatum, don't confuse it. Striate cortex. Actually, 41 is the primary auditory. They have maps in them, all of them. Those maps are retinotopic. Different parts of the retina are represented in here. Those are tonotopic. Different parts of the cochlea are represented in maps of the cochlea. In the postcentral gyrus, we have 312. This is SS1, somatic sensory area 1. And here's somatic sensory area 2. It's 43 down below. It's the anterior parietal lobule. Behind it, it's the posterior parietal lobule. Lobule means small lobe. SS1 is somatic sensory area 1, and there is a map in it of the body. The person is represented in SS1 upside down, remember? First you have the face, then you have a hand, and then you go arm, shoulder, trunk. On the dorsal surface you have the thighs, and the leg and the foot is what? On the medial surface. This is the post-central gyrus. The precentral gyrus is over here. It's area 4. It's a primary motor cortex, or SM1. This SS1 is SM1. There's a homunculus, a person also represented in here facing this one. Identical to it, facing it. Head down, the same kind of map. Yeah. Now, differences that they have asked about that you want to watch for. That's why I'm bringing this up. In the sensory area here, the face is large, the hand and the face are big, the hand and the face here are big. But in the sensory area, the face is larger than the hand. In the motor area, the hand is larger than the face. And think hand is what you do with it, right? Also in the face, in the sensory area, the lips occupy a big region. In the motor area, the tongue occupies a big region of the face. So the largest part of the face in the motor is the tongue. Motor, movement, speech. In the sensory, the largest part of the face is the lips. It kind of makes sense. Lips, remember, for babies, for suckling, for survival in mammals. SS2 is the second map in here. It's much smaller than this one. It's bilateral. This is contralateral. This is bilateral. SS2 is bilateral. Also SS2, area 43, somatic sensory area 2. The anterior portion of it is gustatory. The posterior portion is pain. In front of 4 is area 6. That's a premotor. Premotor is not precentral. Primary motor is precentral. Premotor is area 6. While the primary motor is involved in the distal extremities, controlling the distal extremities and individual muscles, like forearm and hands. Area 6 is involved more in the proximal extremities and the axial musculature, shoulders and back. Area 4 carries out the movement. Area 6 gives you the posture for the movement. So area 6 is posture. In here, 8 is a voluntary eye field. It's in single superior colliculus. Remember, superior colliculus is for visual tracking. The tracking, there's voluntary and involuntary. So for the tracking, you go from the optic tract to the superior colliculus. And that gives you the tracking. It's going to go tectospinal and tectobulbar to control the eye movements and the neck, so you can track. But it can also, so that's involuntary, but you can also go like this from the voluntary area, the visual eye field in frontal cortex. That one would go through colliculus also for tracking, but this would be voluntary tracking. So if you're following this while I'm walking, that's involuntary. But if while you're following, you decide you want to look over here to see what's a cabinet or something, that's voluntary. You have to unlock your gaze and relock it. That's area 8. It's called frontal eye field. It's not vision. It controls eye movements by going to superior colliculus. In superior colliculus control eye movements by going to the ocular nuclei of the eye muscles, trochlear, abducens, and oculomotor. So you have to go to, from here you have to go to 3, 4, and 6. And you have to go also to the cervical spinal cord to control the neck, tectospinal. In here, Broca's area. That's motor speech. Damage in there causes motor aphasia. Right? It's on the left. In everybody, whether you're right-handed or left-handed, it's on the left. If you're ambidextrous, that is on both sides. If you're a female, there is a little bit of speech on the right side too. But so a female can recover after a left stroke. A male probably won't. Also, it depends on the extent, because around it, 45 and 46, they also involve the speech. On the left. In here is Wernicke's area. That one seems to be a favorite too. Wernicke's area on the left is semantic speech, the meaning of speech, not the uttering of speech. We also like to say it's also an area for abstract concepts. And likely to ask you why that would be, it's an area for cortical integration. Which really doesn't mean a heck of a lot. Cortical integration means that things come from different parts and they get integrated here, put together. So an area of cortical integration would be what? Wernicke's area, right away, even though the whole cortex doesn't exist, especially on the left. On the right, you have prosody in Wernicke. Prosody is non-verbal content of speech. That is, the intonations, the punctuation and that kind of thing, emphasis. That would be on the right. Again, speech is on the right, semantic speech. On the left Wernicke. Wernicke, there's right and left. Broca, there's only left. The one on the right is not called Broca. Another area is here, the prefrontal cortex. Something I ask you about. Prefrontal cortex is the region for decision making. It's also for prediction. Before you make a decision, you predict the outcome of your action. In diagnosis, they have another name for it, which is what Guyton uses. It's called what? Prediction is called prognostication. So you see, prognostication is prefrontal cortex. Prognostication. And decision making. The thalamic nuclei, specific and non-specific. Both categories, specific and non-specific, send their axons to the neocortex. The specific ones send their axons, they're all thalamocortical, right? The specific ones send their axons to lamina 4, to layer, not lamina, lamina is important, to layer 4, which is the internal granular layer, right? And the axons terminate on the stellate cells. Non-specific send their axons to the cortex to layer 2, 3, and 5, not 4. Specifically not 4, all the other layers. They don't terminate on stellate. And they're non-specific in that they distribute their axons to many regions of the neocortex, not one particular region. There's a third one that you're likely to be asked about. And tell you which nucleus is the one that does not send axons to the neocortex. Which one is that? The reticular nucleus. Reticular nucleus in the thalamus integrates the nuclei together. It's sort of like a traffic cop. Tells them which one is okay to go and this kind of thing. So there is a third group, the reticular. Not reticular formation, reticular nucleus or group of the thalamus. That's the only one that what does not send axons at all to the neocortex. The non-specific are the intralaminar nuclei. The specifics are the ones we talked about quite a bit. The non-specific are involved in arousal, wakefulness, cortical recruiting. They distribute to many areas of the neocortex, activate many regions in the neocortex. the more of it is active, the more awake you are, right? So intralaminar are not specifically involved in cortical arousal or cortical recruiting. The specific ones are the ones that are involved in identifying the stimulus and figuring out what the sensation is, interpreting the signal. Of those, we had a few. We had the EMG, which is immediate geniculate, which received from where? The inferior colliculus. And EMG sent to what? That's right. Primary auditory cortex, right? That's specific. The inferior colliculus received the lateral lemniscus. Remember that? Which came from where? From the superior olive and from the cochlear nuclei. The ventral one, ventral anterior, went here. The ventral posterior and the dorsal don't go to superior olive, they go straight like that. With lateral meniscus. That ring a bell? Do you remember all this? That's the gist of it here. The signal coming back out again from here to the cochlear nuclei and to the cochlea is the efferent auditory pathway, olivocochlear bundle, right? For the auditory sharpening, because the hair cells still turn them off. Other nucleus is the lateral geniculate. We're looking at thalamus here. Lateral geniculate goes to the striate cortex. Again, specific, terminating layer 4 on the stellate cells. The lateral geniculate receives from the optic tract, which also sent to superior colliculus, remember? And to the pretectal nucleus. If you go now to pretectal, there's the optic tract, you went here, you go from here to Edinger Westfall, which then goes to the ciliary ganglia. We're going to go back over this again. Which then goes to what? Constrictor capillum. And that's the what? The pupillary light reflex, right? Light, constriction of the pupil. I think it's bilateral, because in here you're going to go to the other pretectal. So this would be the direct reflex. This one would be the what? Concentric. The reflex is from the visual system.